Hello everyone, myself is Ashish Kumar Mathur from the Department of Computer Science and Engineering AIML. Today we are going to discuss about the topic set operation in discrete mathematics. In today's session, the contents are Venn diagram and types of operation. Now let's start with the topic Venn diagram. So what is a Venn diagram? It is a pictorial representation of sets and shows all possible logical relation between these sets. It means in set theory, uh, there are many kinds of sets, or we are generating many types of sets. So if we want to represent the sets in the form of diagram or pictorial representation, then we will use the Venn diagram. So main and it also shows the relationship between the different sets. Main objective of the Venn diagram is to represent the sets in the form of diagram. So set operations, there are many various types of the set operations, which are union, intersection, complement, set difference, and symmetric difference. So we will discuss all the types of the operation in the set with the help of examples, and we will see how we represent in the form of Venn diagram with the use of these operations. First type of operation is a union operation. Union operations, here I am taking two sets, set A, set B. So if we talk about the symbolic representation, then union operation is represented as A union B. This is the symbol of union, and A and B are the sets. So how we can define the union operation, or we can say how we can perform the operations between the sets. So it is defined as a set of those elements which are in either A or in B or in B. It means lots some there are two sets A and B. So elements are present inside the set in both the set. So if we perform the union operation between those sets, so so A union means a operation saying that it consists of all those elements which are taken from either from set A or from set B or from both. Means both is the case of the common elements which are present in both sets A or B. So it is a definitions, or it is a main working of the union operation. So it is in generalized form. It can be written as like A union B. X is the name of the elements which are taken, or we can say which are present, which will be present inside A union B set, and it's saying that X belongs to A. X is the element which are taken from either set A, or it can be taken from set B, or it can be taken from both set. So here is the example, like A set A is the given in which three elements are there, 20, 25, 30. And B set is the elements values are 25, 35, and 40. So if we perform the union operation between A and B, then it will be the result of union operations. So how these elements are come after performing the union operation. So according to the definition, it's saying that whatever the elements are present in the union operation, it can be taken from either A set A, or it can be taken from the set B, or from the both. So here I'm taking first elements from the set A, like a 20, 25, 30. So these are the elements from the set A, and remaining elements are from the set B. But here I am seeing that the common elements are, which is 25, which are present in both set A and B, which is written single time. So it is uh, condition is we have to keep in mind that whatever the common elements are there, it should be written in single time, not multiple times. So like 25 and sorry and 25. So it should not be written like this. Suppose I have written multiple times 25 common element. So it should be written like this only single time. So as according to the set property is saying that the element should be distinct. So so we will write only single time. So this is the result of the union operation. So if we want to see this union operation in the form of Venn diagram, we can represent in the form of Venn diagram. So I've taken pictorial representation of the union operation. So here I am taking two sets, which is A and set B. So this is the area of set A and this is the area of set B. This part is the common area, common. So whatever the elements are there, which is a in common elements should be written here. So if we talk about the A union B, so all the elements either from set A or set B. So from set A means all the area, or we can say all the elements of the A are covered. Another is setting, or it can be taken from set B. So all the areas of set B also should be covered. Means all the elements of the B should be covered. Or third condition is saying that it can be from both. Means either means common element. So it can also cover common area. Means common part. So this is the Venn diagram representation of the union operation. Next operation is intersection of the sets. Again, I am taking two sets A and B, and intersection operation is symbolic representation is represented as A intersection B. Intersection symbol is this, and what is the properties or what is a definition? It is saying that it is defined as the set of those elements which are in both set or common elements in both sets. Earlier, I have discussed the union operations. In union operations, I have taken the elements from uh, set A or B or common elements. But in the intersection of operation, it's saying that the intersection option consists of those elements which are common from both sets. Only those elements will be considered which are common, which are means which are present in both sets, either in A or B. So in generalized form, it can be written as x is the element, and according to the condition is that x belongs to A and x belongs to B. Means whatever the element which we taken, it should be belongs to the set A, and same element also should be belong to the set B. Same examples I have taken 20, 25, 30. B is equal to 25, 35, 40. Then if we perform the intersection operation, so common element is there 25. So uh, on the and after performing A intersection B, only 25 elements will be considered. Now I will see the Venn diagram representation of intersection operations. So here I again two sets are there. So intersection, this is the part of set A and this is part of set B. But intersection properties saying that only common elements, or we can say same elements which are present in both set. So here I'm seeing this is the area of the common. So common area will be covered. As if we see with this example, so only 25 element is common. So if we can write it 25 here. So we can 25 elements or we can write 25 value in this area because this is the common area. So this is the Venn diagram representation of intersection operation. Next operation is the complement of the sets. It is denoted as a bar, a dash, or it can be denoted as a c. C denote as a complement, and a is denote represent the name of the set. It is defined as the set of those elements of universal set which are not in set A. It is saying that out of the universal set, whatever the set A is generating, uh, which are not present in set A, then all the results of except the elements which are present in set A is called as complement of the set. Means universal set is the overall set which we are talking, and out of from the universal set, all possible sets can be generated according to the some properties or some conditions. So here I am taking a suppose a universal set is u, and from the u universal set according to some condition or properties, set is generated. Set is generated in which some elements are present. Some elements are present. So A complement saying that it consists of those elements which are not present in A. So those elements which are present in set A will not be considered as a, except those elements which are which are those elements which are present in set A. Except these elements, all the elements which are present in universal set will be the part of A complement. Again, I am repeating. Suppose there is a set, a universal set. From the universal set, some set is generated in which some elements are present. So if we talk about the A complement, so A complement saying I am taking those elements which are not present in set A. So those values are which are present in set A, except these elements except these elements, which is all the remaining elements which are the part of the universal set will be the A complement set. So in the generalized form, we can write as x. X does not belongs to A. Means the elements must not shouldn't not be belongs to the A. So whatever the elements present in set A should not belongs to the A complement set. Or we can write as universal minus A. Let's say U is equal to set of even numbers. Suppose there is a universal set which is taken as a even number set, and in which set A is generated like A 8 comma 12. So 8 and 12 both are even numbers, and if you find out the A complement, so A, what will be the A complement? So set of even numbers except 8 and 12. So in set A, two numbers are present, two elements are there, 8, comma 12. So in if you talk a universal set, so whatever the set elements like even number elements like 2, 4, 6, 8, 12, up to so on. So what will be the part elements will be in A complement set. So those elements will be present uh, set of even numbers except 8 and 12. So from the 8 and 12 accepting not I am not including the 8 comma 12 numbers, and all the remaining even numbers are the part of the A complement except 8 comma 12. So this is the complement of the set. So if we represent the Venn diagram of this operation, so here is the universal set and set A. So this is the universal set which is denoted as U, and set A. This is the set A. So all the elements means all the areas will be covered except the set A. So this is the area of the A complement. Because A complement not including the set A elements, so I will not consider the set A cover area, and remaining areas will be the A complement. So this area will be the A complement. Next operation is difference of set. Or we can say set difference. Two sets are taken, again A and B, and difference of both set, yeah, or set difference are denoted as A minus B. It is defined as the set of those elements which are present in set A but not in set B. So minus B means set difference, saying that it consists of those elements which are present in set A but not in B. Means all the elements that are present, or we can say, or all the elements that belongs to the set A, consider only those elements but not those elements which are belonging to the set B. Or we can it can be in other form also, like a B minus A. So if we taken as a B minus A, so it will be saying that in all the elements that belong to the set B but not set B. So this is a generalized form of the set difference. So this can be at any form, like a minus B or B minus A, according to the requirement. So here I am taking example: A is equal to 20, 25, 30. B is equal to 25, 35, 40. So what will be the A minus B operations value? So after performing the set difference operation, the elements will come out 20 comma 30, because I am seeing that in the set A three elements are there: 20, 25, 30. But after performing set difference means it will be considered those elements which are present in set A but not B. So I will consider 20 and 30. But why I have not taken 25? Because 25 is the common elements. Common elements means it can also be present in set B. But the condition is short, saying that it should be present in set A but not B. So so common element will be ignored or skipped. So whatever the common elements should it not be written inside the A minus B operation. So only two elements are there: 20 comma 30. Now we see the Venn diagram representation of set difference: A, set A, set B. So here it's saying that the elements that belongs to the set A, consider those areas which belongs to the set A. So this is the area of set A, this is the set area of B, and this is the common area. So I will cover all the area of set A. So this is the area of the set A, but I will not cover the common area because I have here I am seeing the common element not taken. So I am ignoring two elements. First element set B, another is common elements. So I will not cover those area. So set B is not covered, common areas will not be covered. So if we saying B minus A representation would be coverage of B. So B area will be covered, and again A area will not be covered, common area will not be covered. So this is the Venn diagram representation of set difference. Next operation is symmetric difference of set. Uh, uh, Again, two sets A and B are taken. So it will be denoted as this with the symbolic representation in this form. So this is the symbols of the symmetric difference. Its definition is given as it is defined as the set of those elements which are present in either set A or in B but not in both. Means it's saying that I will consider those elements in the symmetric difference operations which are present in either A or in set B. but the common element should not be there. Means we ignore the common elements. So whatever the common element will be there, apart from the common elements, all the elements from the set A or from the set B can be taken as in the symmetric difference of set. So here is the example 20, 25, 30, P 25, 35, 40. So I will see 25 is, elements which is the common in both set. So I will ignore 25 elements and will be take all the elements will be taken from the set A or set B. So I will ignore the 25 elements and the remaining elements from set A and set B will be taken as the symmetric difference set. So 20 from set A, 30 from set A, 35 and 40 from set B. So it is saying that from the it can element should be there from set A or set B, but not in but common part not exist. Like as we discussed in union operations, so in that again I am taking the elements from set A or B, but I am including the common element also. But in this part, in this operation, I am not including the common part. So only set A, set B elements are there. And now I will see the Venn diagram representations, how we represent the symmetric difference set in the form of pictorial. So here set A, set B. So it is saying that which are present in either set A or B. Means the area would be covered either from set A or from set A. But I will ignore the common area. So common area will not be covered. So set A will be covered. I am taking the elements from set A. So A will be covered. I will take the elements from set B also. So set B will be covered. But I am not taking the common elements. So common elements are avoided. So common area will not be covered. So this is the Venn diagram representation of the symmetric difference of set. These are the references that I have taken for this topic. Thank you.